Welcome to this session at DynamicsCon. First of all, I'd like to thank you, say thank you to the sponsors of DynamicsCon and say thank you to the organizers of DynamicsCon, a truly awesome conference put together by the community, for the community. It's really amazing to be here. Thanks a lot for all those who voted for my session, which allows me to speak today. Really very much looking forward to sharing the topic today with you. I also want to say thank you to my company, Cosmo Consult, who allowed me to speak today. So thanks a lot there as well. To introduce myself, my name is Tobias Fenster. I'm the CTO for Cosmo Consult, and I'm also a Microsoft MVP, both for Azure and for business applications, with the strongest background in Business Central, and also since very recently a Microsoft Regional Director. Without much further ado, I'd like to jump right into the topic, and the topic is interfaces in AL. But before we get to interfaces specifically and look at how they implement it and jump right into a demo, I also want to spend some time to talk to you about why this matters. Why do we need interfaces? What's the base idea, and what are the benefits? And if you're talking about interfaces as a language construct, then we also need to talk about components as a basic idea of programming. So if you think about how Business Central, how the base application of Business Central is structured, then it very much is a big monolith. That's how software was built in the times when Business Central, or at that time still running under a different name, and it has quite a history of different names, but it was built as a big monolith. It has some kind of structure, of course, but it's not really well componentized. Microsoft is talking a lot about componentizing their base application, and they've also done that. But I think they ran into some limitations with the language constructs that were there, because it became very difficult to do that. So what we basically want to do when we're talking about components is that we want to define the different parts of our application. So we want to make sure that when we're talking about a specific part of the application, we have a common understanding of what that part of the application is, what it is doing, and what the different plug points or the different connections to that specific component or that part of the application actually are. So what we would want to have is, instead of that solid chunk of software or of code, we would want to have something that's more built up out of different parts. So we would want to have a definition of what the different parts, what the different components of our base application are. And the reason for that is that if we have them, they're no longer as tightly coupled. And we will talk in a couple of minutes of what that means. So we have a lot easier way to move them around, to think about the structure that is there. We can easily replace them. So if you think about something like this, that you can see here, if we want to change one of those components, it's a lot easier if we have a very clear picture of what that part looks like. So if we want to make a change, for example, we change that one on the top right, then it would look like this now maybe. And this is now very easy because we know it's shaped like this. It has those properties. It behaves like this. So we can easily take out the one component that is already there and replace it with a new one. And also, it's a lot easier to extend it because we know exactly where the boundaries are. And by just adding something to it, it's a lot easier because now we can make sure that it fits into its place. It fits into the plug points that are there, the connections to different components, different other components. But we can also easily build something new and let the world know that there is something new that has happened in my component. So if we take it one level further and don't theoretically speak about the components, but instead speak about the base application of Business Central, then you can think about, as I said, how Microsoft is going forward with componentizing that base application. And the reason why they build interfaces, at least in my opinion, is that they, as I said, ran into limitations of the language CAL or then AL when they started to think about componentization and in building them. So really, the reason for building interfaces, at least in my opinion, was the need for componentization. And why is that the case? If you think about something like the price calculation, and I'm using that example because that actually is the first component that Microsoft has identified and has defined using interfaces, then if you want to describe what the price calculation does, you need something, a construct that allows you to define what price calculation does and not how it is implemented. That's also a concept that's very important when you're thinking about clean and good architecture of software. Did you think about the components in terms of what they are doing, not how they are implemented? Because then it's a lot easier to replace them and to talk about the connections between them, and not worry about if I change that part, then I know there's that implementation detail, and because I changed this, something else is broken somewhere else. I just know the outlines, I know what the component does, and that's enough to think about the structure and the architecture and what it means to change them. And also, it's a lot easier, as I already said, to replace them. So now that we have a clear idea of what the price calculation does, the features that it has, the functions that it needs to provide, it's easier to just replace it. So if you want to bring in your own code, either during runtime or during design time, it's a lot easier. Just imagine you get an invoice, and based on the country where that invoice is coming from, you want to do a different kind of tax calculation. If it's a German customer, you want to have German tax calculation. If it's a Danish customer, you want to have Danish tax calculation. And of course, you can implement this with if-else or something like that, but you can also have different price calculation components. And if now it's the German one, you talk to the German implementation. And if it's the Danish one, you talk to the Danish implementation. And it's very easy to make sure that you're meeting all the requirements that your component has, because you have a very clear understanding what it needs to do and what that particular component wants to do. Or for example, you have a legal change. At the 1st of January, something different is happening. You need to calculate your prices differently, taxes, whatever. Then you could have a component that is working from January the 1st. You have a component that is working until December 31st. So then you have a switch in between. And when that change happens, the new component is used. Before that, the old component is used. And what this also brings us is something that was missing in the current way how extensions in Business Central work. As you might know, there is no way to change existing code or to change standard code that is already there. And now that we have the idea of a component, if that code is part of a component, you could decide to take out the whole component, replace it with your own. That would mean that you are able to override standard code because the whole component is different. Of course, if you just want to change a line or two, then it might be too much overhead to kind of replicate the whole component and put your own code in it, because you need to maintain it, you need to make sure that it's always updated and that kind of thing. But at least it gives us a mechanism. So if you're really hitting a hard barrier where you need to absolutely change that piece of code, it's not working otherwise, then now we have a mechanism that would allow us to do this if it is defined as a component. And also to extend it, again, as I said, now that we have a clear idea what the price calculation is doing, if I want to include some forecast, some artificial intelligence, then this would be a way. If it's defined as an interface, we could add additional functionality easily behind it, or we could add it as part of the interface, as we will later see, and make sure that we have new extended functionality. Now, a couple of minutes ago, I talked about tightly coupled code, and I want to spend a couple of sentences on what that actually means and why it matters when we're talking about interfaces and when we're talking about components. Coupling essentially means how much interdependence there is between different parts of our application. So how much they are connected, how much they are actually linked to each other. And that matters because if you have very loosely coupled code compared to very tightly coupled code, it's like the difference that I will show here. I hope you know that game called Jenga, at least in Germany, where you have those different blocks. And while they are very loosely coupled, it's very easy to pull out things and to put in new things. You don't have to worry that the whole thing is going down. If they are more tightly coupled, so to speak, so they're really very, very much connected, then something like this will happen. And this is very important because if you have something that is very loosely coupled, that's considered good architecture because you can change the different parts. You can adapt to customer needs. You can easily innovate and make changes to the different parts of your architecture without the whole thing collapsing. And that's the reason why the difference between a programmer working on loosely coupled code and one that's working on tightly coupled code is looking like this. If you have loosely coupled code, if you have a good architecture, very well componentized, then it's easy to refactor, it's easy to work on technical depth, it's easy to work on innovation. While if you have everything very tightly coupled, you always have to worry if I'm changing something here, something else is breaking somewhere else. So the idea of coupling, or actually decoupling or loosely coupling stuff, is very important when you think about good architecture, easily maintainable code, and code that is easy to change easily in the future. So what I mean by that, when we're talking about decoupling, is to give you an example, something that looks like this. If you imagine we have a report that talks about sports evaluation. So basically, we want to have an evaluation of the different sports. So we could have a report that has a get basketball evaluation code function, and it has a get tennis evaluation function. So the first step in decoupling those would moving that code outside of the actual report of the design part and bring it into code units. So we have a basketball code unit, we have a tennis code unit, and we move our functions over there. Now we no longer need the different names, so we can just say both are get evaluation because it's clear one is part of basketball, the other is part of tennis, so we are there. Now you might think, okay, well, this looks very decoupled. There's no strong connection between those, but actually there is. There's a very strong connection, and the reason for that connection is that if you think about something like this, the actual code that is happening inside of our report, then it needs to hold a reference to the basketball code unit, and it needs to hold a reference to the tennis code unit. Those are very strong explicit links that are happening between the report and the code units. So they're, as I said, tightly connected, tightly coupled. So if I would consider to remove one of those, basically get rid of the tennis implementation, then I would be in trouble because that just doesn't work. It doesn't compile anymore. It doesn't work anymore. I have a problem. And a flexibility like this to just move out parts, bring in new parts, that is why it's important to decouple stuff. So how would we achieve that? If we still think about our base scenario and we have those links, then of course it's important to get rid of those links. So we don't want to have them. And the steps to get there are, the first one is we need to define an interface. So as I said, the interface has the job to define what my component is doing, not how it is implemented. So what I want from that particular implementation or that particular interface is I want to have a get evaluation. So the only thing I define is a function called get evaluation, and that defines that my component needs to be able to provide an evaluation. And in a minute, we'll see how that looks in actual code. Then we need a list of implementations because somehow the system needs to understand what implementations are there, what sports are there to evaluate. And we need a mechanism that makes the decision, now I want to use this implementation, now I want to use that implementation. To get back to my example of before with the legal change at January 1st, that implementation would know until December 31st, I need to provide that component. And from January 1st, I need to provide another component. So how does this actually work? The sports evaluation report only thinks about the interface. It only has knowledge about the interface. And on the other hand side, the basketball evaluation code unit and the tennis evaluation code unit need to adhere to that interface. And that's called implementing the interface. So they have kind of a reference to that interface as well. But there no longer is a direct connection. Then, of course, the basketball and the tennis evaluation need to be part of the implementation list. So the system knows there's the basketball implementation, there's the tennis implementation. And then when the report comes in and asks for an implementation, it should get back a list. This is a possibility, this is a possibility, this is a possibility. And if we have that list, then, of course, we also need to make the decision. And that's what the call mechanism or the implementation selection part is for. It gets a call by the report asking it, now I want to have an implementation in those circumstances. It looks at the implementation list and then makes a decision which one is the right one and forwards the call to the right implementation. So in that case, the sports evaluation report might have asked for a tennis implementation and it would have answered with the tennis evaluation code unit. And the big benefit of that, if we are in that place, is that we no longer need the direct connection to the basketball code unit and the tennis code unit, because now we can replace it with a variable of the type evaluation interface that we have. So now we can only use that one. And that means that we no longer have any direct connection between the different parts. The sports evaluation report only knows about evaluation interfaces, and the implementing code units, basketball and tennis, just implement that interface. And that way we get that connection without directly coupling them, without directly connecting them. And now it's easily possible to just remove that one, because then it's no longer there, but nothing is broken. Because the sports evaluation report still only knows about the evaluation interface. That one is still there. We just have one implementation less, but it's not breaking anything. It's still compiling, it's still running. The tennis functionality, of course, is no longer there. But if you decide to retire a functionality or whatever, then that kind of is the purpose of everything. We also can easily replace stuff. So if you want to bring in a new tennis implementation, we just add that code unit. Of course, that one also needs to implement the same interface. So it needs to adhere to the same requirements. It needs to implement the same functionality. It needs to make it known to the implementation list that there is now a new implementation, in my case, the new tennis implementation. And it needs to let the mechanism that makes the selection know what the requirements are, what the circumstances are when it wants to be called. And also adding new stuff, of course, is very easy. I'll make a little space here, and then I add a soccer evaluation. And that one, of course, again, needs to implement the same interface. It needs to be known by the implementation list, and it needs to be known by the selection mechanism. So with that idea, now that we have decoupled code using interfaces, we can easily replace stuff. When we can easily add stuff, we can easily remove stuff. But we also talked about extending. And extending is something where you can go two different ways. The first one would be to actually break the implementations that are there. The reason for that might be that you have, again, maybe a legal change, or you have something where you say, okay, this is a new feature. Everyone else who's building on top of my solution, everyone else who is implementing this needs to also provide the same feature, because otherwise the user would be disappointed, or it doesn't work for the user anymore, or something like this. So in that case, what we want to do is we have an interface here. It still has the get evaluation. And let's say we want to have a graphical representation as well. This is the cool new feature for our newest release. So whoever is providing an evaluation absolutely also needs to provide a get graph functionality. So we just add this to the interface. And now in this current state that you can see, the interface is now defined as get evaluation and get graph, but the evaluation code unit that you can see doesn't have the get graph functionality. So that means that the compiler will let whoever is creating that code unit know that this no longer works. That's broken. So we have extended it, we broke it, and of course the remedy for that is to just add the functionality get graph. And it's very easy to call it, because we can just use the same evaluation interface method and bring it in and call a get graph. So that would be the scenario where we want intentionally to break everyone who has implemented our interface, because we have a required new feature, we have a required new functionality that needs to come in. But also we could do it in a non-breaking way. That also is very easy using interfaces, because in that scenario, we would just add a second interface. So now we have the get evaluation interface that provides a text evaluation, and then we have the graphical interface that provides a get graph evaluation. And that one can also easily be done, because the code unit is still working. It's currently not implementing that interface, but we could easily add that function and tell it to also implement that interface. And now it has that additional functionality. If that is something that is optional, then it might be fine to just show a message that current implementation doesn't provide that feature, something like this, or you have a default that always works. But the provider of the specific implementation could also decide to implement that functionality, to add that implementation, to add that interface and implement it. And then it would add the get graph functionality and would get the new feature and be compatible again with the whole stack. But if it doesn't decide to do that, it still wouldn't break, it still would compile, and it still would be usable by the customers. If we would want to use that new interface, then we would, of course, need to have a new variable now for the graph interface, and we would call the function on the graph interface. Actually, that should be get graph, now that I see it, because now we want to have the graphical evaluation. Okay, so much for the theory. How does it actually work? How does it actually look like? We'll jump right into a demo. How do we do this? What we will do, just to let you know in advance, is we will define an interface, implement it, create an implementation list and a handler. We will use the interface so you can see how it actually looks like from a user perspective. We will add a new implementation, and then we will extend it in a breaking and in a non-breaking way. So let's switch over to my demo workspace. And that is here. Okay, so what we have here is a workspace with 2 parts. And I'll start the demo mode, just 1 second. So you can always see what I'm typing. So we have the base implementation here. That's where we will implement the base functionality, and we have the additional implementation that we will use later. In the app.json file, if you know how that is structured, it just defines our component that we have, and it has the platform and the application of the recent release. So this is nothing special in here, nothing that you need to activate or enable. Now, if you want to add our interface and implementation, I will interface and implementation AL, just add an AL file. And then to create an interface, there is an easy to use snippet called tinterface. We will call it sports evaluation. And the procedure that we've seen is get evaluation. And as I said, the first one is a textual one, so we will just return text. That's it. With that, we have defined our interface. We have defined the thing that we wanted to do. We wanted to provide an evaluation as text. Now, to implement that one, we will add a code unit. And let's get an ID for that one. Let's call it basketball. And this one now implements a interface, and we can already see, okay, we get that one here. I'll remove everything that is pre-existing and just look at the error here. And it says basketball does not implement the interface member. The reason for that is because we don't have the procedure get evaluation, and we can easily say quick fix, implement the interface, and then it's already there. In case you don't have that particular setting, the thing that you can do is you go to the settings of the AL language extension. And then there is a particular setting that is off by default, which is the enable code actions. So if I just switch it off to show you, go back here, remove the implementation again, and look at the error message. Now you can see there's no quick fixes. If I go back into the settings and enable the code actions again, go back in here, hover over, now you can see there is the quick fix to implement the interface, and now I have it. So if you want to use that and it's missing, then just go ahead and enable the code actions and you should have it. So what we want to do here is just provide a quick text, as it's just a demo, and we will say basketball is cool because I like basketball a lot. Here we go. That's our implementation. You can see the error is gone, and whenever we call that one, it will just return basketball is cool. Now, as we said, we want to provide an additional implementation. So let's copy that one, give it a new ID. Tennis, it's still implementing, and then we say something like tennis is fun. Okay. So now we have our interface, so we defined what the component is doing. We have implemented 2 components called basketball and tennis, which are implementing the functionality that we want to have. Now, the thing that we need is we need an enumeration. That's the mechanism that Business Central is using that provides a list of all the implementations of our interface. That one also needs an enumeration here. It needs an ID. We call it sports evaluation provider. And that one, again, also implements our interface, sports evaluation. Now with that, we can say we have a value of, let's say 1, because that's where we want to start. And that would be the basketball implementation. Basketball over here. And we say that this is providing an implementation for our sports evaluation interface, and that is basketball. You might wonder why we need to add the sports evaluation part here, because we already mentioned it above here. But when we come to extending and non-breaking changes, then you will see why this matters. Again, we have not only one, but we actually have two implementations. So I will add the value 2. And this is NS. And of course, this is done by the tennis implementation. Okay, so now we have the list. What we can also provide is a default implementation. So this kind of is the fallback. If nothing else works, then we will have the default. For that, we just add another value. Call it 0. And this is the default. And now we need to provide a default implementation for it. I don't want it to be the basketball implementation because that's kind of a specific implementation, but instead I want to define another one. So I'll just copy and paste again. Give it a next ID, call it default, and that one is just providing a default answer, maybe something like this. So we're basically asking the user to do something, but he's not running into an error. Instead, he's getting a meaningful answer. You could, of course, also throw an error to let the user know that he needs to set up something, but by using the default implementation, you still have a meaningful fallback. And to let the implementation or the enum know that there is a default implementation, there is this property, and we can tell it that for our sports evaluation interface, the default implementation is just called default. And that should be fine. The implementation part doesn't matter anymore because now we have a default implementation, so we don't need to explicitly specify it. And we could maybe add an empty caption in that case. So usually you need to explicitly define the implementation, but if you have a default implementation defined over here, then this is no longer necessary for all the values. And again, when we talk about extending, you will see why this matters a lot. So now we have the list and we have a default. Now we need a way to store the currently selected implementation. So this is basically the easiest way to make the decision which of the implementation is used. We just define a setup table. As I already said, this could be something completely different, something more advanced that is calling an external web service or has advanced logic to make that decision. But in our case, we will just define an easy field. That one is our selected sports handler. I need to put it in quotes. And this is of the type of the enum. So now we have the one that is selected. We don't need anything else that's in here, so just get rid of it. So now we have a way to store in the database which of the different implementations that we have defined is now currently selected. And then we need to have a page to make changes. So I'll just add additional page. Call it sports evaluation setup. Set up. Now I got it done. And we will use that one to just show the information that is stored in our sports evaluation setup table. So as a layout, we don't want to do a lot. We will just give it exactly one field, the one that we want to have, which is our selected sports handler. This is where it's coming from. So now we have an easy table that we use to store the current selection, and we have a page that we can use to make changes to that selection. So the last thing that we now need is a code unit that helps us make that decision, that an implementation or a user of the implementation could question what is the currently selected implementation, and we call that sports evaluation management. That one has exactly procedure, and I'm using a snippet for that one again. It's not a local one because we want to use it from somewhere else. It's called get handler. it gets a variable, let's call it sports evaluation, from the interface that we've defined. Sports evaluation. And we need two variables. The first one is our sports evaluation setup table. So we have a record on that. And then we have our sports evaluation provider, which is the enum, the list of implementations that are there. And all that the implementation does is it clears the record. And then it looks at our sports evaluation setup table. If something is in there, I'm not doing anything fancy. I'm just looking for one entry. And if it's there, then we will assign our sports evaluation variable, the one with the interface, to the currently selected sports handler. So whatever is defined here will be defined as the value for our variable. And then we can also have a fallback, and that, of course, is our default implementation. So just to quickly recap, what we're doing here is we're bringing in a variable of the type of the interface, so that one doesn't know what the implementation is. Then we're making a decision which implementation we want to use. That is happening by just looking at our sports evaluation setup table. And if we come to a good decision, then we use that because something is set up. That's what is happening here. And if we really can't make a good decision, then we just use the default as our fallback. Okay, with that in place, we now have everything. To again quickly go through the components, we have the interface, we have our two code units that are providing specific implementations, we have our default code unit, which is providing the default, we have the enum, that is basically the list of implementations, we have the table and the page that we will use to provide a setup and to make the decision which implementation we want to use, and then we have our management code unit, which helps us take that decision. Now with that set up, I will just add a new file here. Say, sorry. Let's do it like this. And this is the one where we will use our interface. And that's as easy as just providing a page extension. So we want to extend the customer list page. As you can see, I don't extremely worry about naming conventions. We have symbols, so we need to download symbols. So we have all the references. I wanted to disable that to a lot of information. Now we have it downloaded. Let's go here and say customer list. Second. And all that we want to do is to add a specific action that is returning, here we are, that is returning the evaluation that we've defined. So all that I want to do is I want to use an action, make it the first one here, and we just give it on the default. Let's make it promoted so we can easily find it. And let's make it big also. And then there's a trigger, what is happening when you click on that action. For that, we need a reference to our interface. So we define a sports evaluation method here. And the second thing that we need is our sports evaluation management code unit. Well, and now we're just calling it. So as you can see, again, we're just referencing the interface. We're not referencing one of the specific implementations. And then we're calling the management code unit and ask it for the current handler, putting in the sports evaluation variable. And now we can just use that one. it is now kind of connected to the right implementation that we have set up. So if we call sports evaluation.getEvaluation, we will get the text that is defined in that particular implementation. With that done, I will just publish, hit F5, and then hopefully my browser comes up. It's publishing, and publishing is done, and I'll show you the login page. And because this is a generated sandbox, I'll put the password here. And then hopefully we should be logged in and be able to navigate to page 22. And that one should show us our action. Here we are. And we have our action. And it says every sport is better than no sport, because currently we don't have anything selected, so it's falling back to the default. Let's see if we can set up something. So for that, I go to the sports evaluation setup page. If you remember, that's the one that's just connected to our table. I create a new record because currently it's empty, and select basketball. That's the first one. Go back here and again call the action. And now we can see, okay, it's connected to the basketball implementation. So that's where we are. And just to show you that it really works, we have our evaluation setup page again. I'll switch it to tennis. Yes. Go back here, call the action, and now we have the tennis implementation, which is connected to it. So you've seen that is basically the most easy implementation that we can do, the most simple setup. We have two components, we have the default, and we can easily switch between those two. Now, what would happen if someone else from a third party would come in and say, okay, this is a cool feature, but I want to provide something else. I want to provide a different implementation. Let's see how that works. If I go back to that one at the additional implementation, the thing that that person would need to do, it would need to add a dependency to the sports evaluation main app, because that's the app where we have defined our interface. So we would need that to make sure that they have the base implementation. As you can see here, this is also automatically created by Visual Studio Code. We already have that implementation in here. So what we now want to do is we want to provide an additional implementation. So I will just add, no, not here, rather here, a new file called additional implementation AL. And I will add a code unit. Make sure I'm hitting a different ID. Let's do soccer. And implementing sports evaluation. I'll once again remove everything and just use the quick fix to, if I could use it, here we go, to implement the interface. And then I have a bit of a controversial idea about sports. So this is my take on sport. Now we have a different implementation, but we don't have added it to the implementation list. If you remember, that was the enum. We define it as extendable, so we can do an enum extension. This is the soccer extension, and it extends the sports evaluation provider enum, and then we, of course, give it its own ID, soccer, and the implementation of the sports evaluation interface now is to be defined in the soccer code unit. And that's it. Nothing more that I need to do. I just provided my next implementation, and I provided it to the implementation list. So if I just hit F5 again to publish it, and then it should add that implementation, and we can directly use it. So let's see. The interface is missing. So let's do a download symbols again. And then hopefully it should work. Let's try F5 again. Now the symbol download has finished. go. It's publishing. And then hopefully the browser should come up. Here we are. If you remember, the last thing we did was to change the implementation to tennis. So now that we have a new implementation, we need to make sure that we're setting that one up. So I'm going back to our sports evaluation setup. And without anything else, just by installing that additional extension, now I have soccer in here. Yes. And again, nothing else that I need to do. I just call the same action again, and now it behaves differently because we have provided different implementation and made sure that that particular implementation is now selected. So you can see it's actually very easy to provide an additional implementation if we have that component definition. If we have that interface in place, then it's very easy to add something new, to just bring in new functionality, because we exactly know what we need to implement. We exactly know how it needs to behave. And that way, there's not a lot we need to think about in that area. Okay, so now we have our base implementation in place. Let's imagine we want to do something else, and that is extending. So as I said, there are two ways we can implement in a breaking and in a non-breaking way. To just start with the breaking way, let's just add an additional procedure graph. So now you can see I get an error here. It says basketball does not implement the interface member sports evaluation get graph. That of course is correct because I've added a procedure to the interface. I didn't implement it in my code units because at that time I didn't even know that it was there. So now all my implementations are broken. Also, of course, as you can see here, the additional implementation is broken because that, of course, looks at the same interface. So if we go back here, remove that one, the thing that I now want to do is to show you how we can do this in a non-breaking way. And of course, the answer is an interface again. So what we do is we provide an additional interface called a graphical sports evaluation. And that one has a functionality that's called getGraph. Of course, in reality, that would return something else than a text, but just for demo purposes, let's keep it a text. And as you can see, if I now save that one, nothing happens because currently the implementation list doesn't yet know that it needs to provide an implementation. So if I say that all my things in the list here need to also implement the graphical sports evaluation, then now we get an issue because the default implementation doesn't provide it, the basketball implementation doesn't provide it, and the tennis one doesn't provide it. So you might say not a lot that you have done, you just broke in a different place. But what I can do with the default implementation, I can say that the default also implements the graphical sports evaluation. Again, use that nifty quick fix, say get graph, and then we just add something here. Say, unfortunately, this sport doesn't know about fix. Okay. So here we go. Now we have a default implementation that provides that functionality, and we need to let the enum know that we also want to use this as a default implementation for the graphical sports evaluation. That's why I said before that we need to provide that information because enums can implement multiple interfaces, and then we need to make sure that we define the one that we want to use now, and that is the default again. And I don't need to have. Actually looks like this. And now, as you can see, I don't have any compiler errors anymore. If I look at the problem view here, I don't have any issues here because I provided a meaningful default implementation. I separated the interfaces, and by that now it's up to the different component to just implement their own functionality if they want to, but they don't have to. So if I now am calling the basketball implementation, it will just fall back to the default and use that one. Or if I'm calling tennis or soccer, all the same. But of course, what I can do if I'm someone who wants to provide a nifty implementation here, I could say add a procedure again. And that one is called graph. And I, of course, could have used the quick fix for that. And let's do it that way this time. And we say this is a fancy graph, which is a lie, but doesn't matter for now. And then what I need to do is add the graphical sports evaluation over here and need to let the procedure know that it turns text. So now we have implemented it. That means that we have a different implementation in here. And then to let the evaluation know that, or the enum know that we want to provide that one as an implementation, we would add the graphical sports evaluation. That one also is basketball. And we need to change that to that way, we have let the enum know that if someone is calling the basketball implementation, it needs to bring in the basketball implementation as well for the graphical sports evaluation, but for all others, we just want to use the default. So that way, it's kind of easy to make that distinction, to make sure that we bring in new functionality where needed without breaking anyone else, or making a conscious decision to break someone else because we want to have that particular functionality. So as a designer of the architecture of your base software, you can be very clear of what you want. You don't necessarily need to break people, but you can break them if it's absolutely needed. So with that, I'll jump back into my presentation because I hope I covered all the things that I wanted to show in the demo. And just to do a quick recap, why do we need interfaces? Because we want to componentize, as we said. We want to break up the big monolith into different components because we want to have decoupling. That makes it a lot easier to add stuff, to remove stuff, or to replace stuff with something else. And it makes it easier to extend existing components. And the other direction also is true. If you want to extend something, or if you want to add, remove, or replace something, then you will first need to decouple it because that makes it a lot easier. That means you want to componentize it. And there, of course, the answer again are interfaces. And because of interfaces, we can all easily do that. It's very easy to create. It's very easy to set up. As you've seen, it just took something like 10 minutes to set it up. Of course, there was only a demo implementation, but you've seen there's not a lot of overhead of boilerplate code that you need to create. It's just very easy and straightforward. And I would really encourage you to think about using interfaces in your solution because it makes it a lot easier to think about architecture, to change stuff, and to just decouple code and be happier about changes. If you want to have more information about the topic, there was a very good session by Nikola Kukrika at the 2020 Wave 1 virtual launch event for Business Central, and I've provided the link here. I would encourage you to watch that. He adds a couple of additional wrinkles to what I've already shown you. So really very, very recommended session. And with that, I'm done. I want to say thank you for watching. Thank you for listening. Again, thanks for voting for my session. I really appreciate it to be here. And once more, thanks a lot to the sponsors and the organizers of DynamicsCon. Truly amazing effort and an amazing conference. Thanks a lot. And next, please join me in the Q&A for additional questions that you might have.